All right, we're ready to go. Hello and welcome everyone. My name is Pete Keeler, part of the VCF product team here, and we're going to talk a little bit about vSAN design and sizing. Now, it's a big topic, way bigger than the 25 minutes that we have. So we're just going to run through sort of rapid fire tips and tricks that I recommend for building out a vSAN cluster in a way that's really going to increase the odds of success. I'm just going to run through these fairly quickly. And you know, one of the things when I started sort of thinking about what was going to be a part of this presentation, I had to think back about, well, what are the things that seem to hit most customers? When you have something like vSAN, we need to remind ourselves that it's a fully distributed storage system. So what does that mean? When you're writing data across multiple hosts in a vSAN cluster, that means that the network is fundamentally important. Now, when we are thinking about a vSAN cluster, we rely so heavily on that network to make sure that the data is written in a highly resilient way and that it provides the control plane mechanism for your environment. Now, this is the same thing in the same sort of setup that you would have in a three-tier architecture, but it's especially important in a vSAN environment, whether it's a fully aggregated vSAN HCI environment or if you choose to disaggregate the environment. So we're going to focus a lot of the tips around networking in general, but of course if you have some burning question after the presentation, just feel free to grab me afterwards and we'll sort of touch on that. So why do these things end up becoming such a challenge in the first place? Well, there's a few different reasons. One, of course, is that, you know, when you have a traditional three-tier architecture and a storage array, a lot of times that's just sitting in its own fabric, isolated, managed maybe by somebody that doesn't have anything else to do other than manage that storage array and the fabric. Well, with a hyper-converged arrangement, we are relying on the IP-based fabric to provide that fabric. Next up, of course, is the fact that when we write data, we distribute it across multiple hosts within a cluster. So therefore, you know, once again, you're relying on that network. Next up is that when you think about, from a networking perspective, a lot of times as a virtualization administrator, you know, you're provided a network by the network team, but all you really see are the switches that live up at the top of rack. You really aren't aware of how those switches are interconnected in that, let's say, a spine leaf network. What's the oversubscription ratio? How are the interconnects occurring within the top of rack switches and so forth? So this can be very problematic. And the end result can be that from a consumption standpoint, you have these scenarios where if you do these other things wrong, maybe if you design them wrong, ultimately it's going to be perceived as vSAN is not working maybe the way that you had hoped. So we're just going to run through some really quick, simple tips, but if you have any additional questions, you can ask me afterwards and I'll be more than happy to answer them. So first up, use natively fast networking. This is something that, of course, we've encouraged ever since the dawn of time, really, since the debut of vSAN. But it's especially important as we have transitioned over to vSAN Express storage architecture, which is so capable. But you have a scenario here where you're only as fast as the interconnects between those respective hosts because we have to write the data synchronously. So if you're thinking, you know, I bought those 10 gig switches back in 2014, they're still pretty good. Not really, you know, they just aren't. We see a lot of issues and a lot of challenges where you did a really good design on the hosts themselves, but the networking was really undersized. And the other thing about 10 gig networking is there were a lot of switches that were sold and advertised as 10 gig switches, but they were extremely underpowered as far as the ASICs that were powering those available ports. It couldn't support the high number of packets that it needed to process this data in this east-west traffic across a vSAN HCI cluster. So when you think about from a design standpoint, you know, you have extraordinary advances from a CPU perspective. You have, much faster storage devices. You have even much faster host-based networking, and maybe higher demands, higher requirements on those VMs. But if you ignore this part, it's really not going to be good for you. So I would encourage you, when we think about the costs and the overall solution, just be mindful of that. Modern day storage or modern day switches that are fully capable for storage-based processing are extraordinarily cheap. You can buy street prices for a 48-port 25 gig switch is about $7,000. So that's knowing that your server costs can get quite significant these days. That's really relatively affordable. Now, when we think about the design of vSAN within your racks that you have in your data center, we need to also think about the fact of where this data may be traveling. So let's say we have a vSAN cluster that's living in a single rack. In this particular case, the east-west traffic for this vSAN cluster will likely just remain within the top of rack switches. That's the overall design goal. But if you did have some other vSAN clusters or a single vSAN cluster spread across multiple racks, or in this case, you have vSphere clusters mounting the data store to a vSAN cluster, that means that you're going to have storage traffic that traverses over the spine. So that's one of the things that I would highly recommend. Is it's a great opportunity if you have a network team, and you usually try to avoid talking with the network team. This is probably a good time to begin your conversations. Help them help you understand what that connectivity is like across the spine, because that's ultimately going to potentially be the bottleneck. If you have client requests coming from here to the storage cluster, and you look at the storage cluster and you don't see any any issues here, but you're seeing latency as seen by the guest VM, it may very well be the traversal across the spine. So next up, and I get asked this a lot, well, what about, how about link aggregation? That's great, isn't it? Well, it can serve a purpose, but generally for host-based connectivity, I don't like it and I never recommend it. But there's a hidden cost to it that is beyond the technical reasons why I don't like it and I don't recommend it. One is that it burns up your port counts within the switches themselves. So if you are lagging 4 uplinks or 6 uplinks or something, if you have a 32 port switch, you're going to run through those ports fairly quickly there. And it's really difficult when you have a rack that is 42U high and you're looking to try to introduce as many compute nodes or storage nodes as possible. That's going to be a struggle. Next up is just reminding yourself of the cost per these ports. Even when they're slow, the cost per port is very similar to the cost per port of a 25 or even a 100 gig switch. So that's, again, just something that we need to be mindful of. The next problem that comes up when you are doing something like this is that you're stranding the other resources that you already paid for within the host. So imagine in this particular case, you're lagging multiple 10 gig uplinks here, trying to get as much throughput as you can. It's not really working out all that well because lagging generally doesn't work out all that well. And as a result, those brand new ready nodes that you purchased, you are really constrained by the network. So you're not able to take advantage of all the CPU, all of the memory, all of the effective throughput that those high-speed NVMe-based storage devices can handle. And next up, of course, is that when you look at the actual costs within the server itself, there is next to no difference between the cost of a 10 gig switch or a 10 gig NIC and a 25 gig NIC within that port. So I just always recommend, even if you're running a 10 gig switching right now, go ahead and spec 25 gig or higher, it's going to auto sense down to the speed that your switches are, but then it's going to be sort of future-proof for when you introduce new switchgear. Okay, so next up, this one comes up a lot, so want to make sure everyone's clear on this. Strive for simplicity in your ESXi configuration when it comes to networking for vSAN. What I recommend is using an active standby teaming policy for your vSAN VM kernel port, and that's route based off of originating virtual port ID. And the reason is that when it comes to storage traffic, you want a predictable path from point A to point B. When you have something like, let's say, active-active, which is even right now, in some senses, a default of VMware Cloud Foundation, active-active was really geared for scenarios where you're actually using those multiple uplinks for the purpose of VM workloads, not storage traffic. That's a very deterministic-based service, and you want that as predictable as possible. When you're setting this up, of course, also make sure that on the switch side that you've looked at some of the settings here. Maybe if you have a network team, ask if you can see the startup or the running config of that switch. And because if you just ask, is the switch okay, they're going to say yeah. But they don't know, maybe they threw on some QoS there that they've limited the bandwidth capacity. Well, when you built out this high-speed storage system and they've artificially throttled it at the switch, then you may not have the results that you expect. Now, next up, of course, is LACP. Would I recommend it? Generally, no. There's a couple of reasons why. LACP strives to use as many uplinks that are in that bond, but it's not necessarily a 1 + 1 = 2 scenario. It's a best effort scenario, and it's going to balance that traffic based off of the originating and the source and the destination port IDs. It's an optimistic way of providing that balance, but when you have multiple sessions that are providing storage services, it doesn't always balance out. And it can create problems as well in a network environment where you have a true cloth-style spine leaf arrangement where you have no interconnect between the top of rack switches, because that storage traffic will then traverse the top of rack switches up to the spine. So really what you want when you have a vSAN cluster, and I'm only showing a couple of hosts here just for illustrative purposes, we want this path from point A to point B to be as free and as open as possible. That's so that when you have these high-speed storage devices and you're writing to those devices, that it can satisfy the request and write that data in a highly resilient way. If you have a bottleneck that is up here, you're going to be looking at the monitoring here, and it's going to look fine, but it's being constrained up here. All right, so when it comes to your ESXi host configuration and how we would really generally recommend this setup, here's a good example. Now, I'm going to show a couple examples, one with a 2 NIC configuration where each NIC has 2 ports on it. And then this one, I just show a single NIC with 2 ports on it. In this particular case, what I show is a vSAN storage cluster or a vSAN Max cluster where we're introducing a new traffic separation feature where we can have the back-end storage traffic be on a different VM kernel port as the front-end guest traffic. So what I would recommend here is that you have 2 VM kernel ports here, one for the vSAN client traffic that's going to VMNIC 0, and then the other vSAN traffic for that back-end east-west traffic going to VMNIC 1. Those would be set in an active standby arrangement where each one is flopped so that it's using the other's standby. That's the best way that you can take advantage of the existing resources that you have in that environment. Now, in this particular case, this is the very same setup, but just with a couple of NICs. This is, as a whole, I would always recommend a couple of physical network cards because that's going to protect you against failure of that actual NIC. Now, modern day servers, sometimes they make this a little difficult for you to actually see if they're two or not, two physical NICs or a single 4-port NIC, but you get the idea here. This is the desired goal in most situations. If you have other VM kernel traffic like vMotion and things like that, you would want that just simply on one of the other uplinks that is opposite of what your primary vSAN traffic is at. So I was mentioning a little bit before about the unintended consequences of link aggregation as a whole. And sometimes, let me first clarify, when we talk about link aggregation, it can come in a couple of forms. Link aggregation in the ESXi standpoint, you can have an active-active arrangement using something like load-based teaming, and that's going to try to balance that traffic across those multiple uplinks. Or you're going to have it at another level using a physical bond that is occurring at essentially the host and the switch level, known as LACP. But the implications of sort of an active-active teaming are the same here. So what happens here in a top-of-rack switch for a 3-tier topology, when you have an interconnect, most of the time these days it's an MLAG, is that if you have your active and standby uplinks going here, it's going to, and in fact, if they're done properly, they'll just stay in a single switch. But if you have active uplinks coming from the host, it's going to use this interconnect to satisfy the actual communication. But in a spine leaf topology, there's no guarantee that there's an interconnect. In fact, that's the whole idea about a spine leaf network, is it's a non-blocking network so that you don't have to run things like spanning tree in order to prevent these loops. But what can happen here is that, just as I was mentioning earlier, you can create a scenario where you have storage traffic that you think is staying within the top of rack eventually hit the spine itself. Now, in one sense, this may not be a bad thing if the design was built for that, but a lot of times people spend a minimal amount on the spine, and if you end up becoming oversubscribed in this scenario, this can run into performance challenges. And I just show, by the way, that it's just hitting one spine switch. That's actually not true. I just did it for illustrative purposes. It would potentially be hitting all spine switches, which is even worse. Okay, so next up, from a design standpoint, a lot of times we're certainly when you're building out a new data center or you're refreshing an existing data center, you want to try to make it right? I mean, you're trying to do the right thing. And so because of that, you're trying to analyze every aspect of it and make those right choices. The problem is there's a lot of unknown unknowns, and we're just, you're just trying to make the best decisions possible. What you can do with vSAN is that you don't necessarily have to look at the total picture and know what the answer is right away. We can start knowing that we are going to change at some point in the future. So let me show you what this looks like. In this particular case, what I'm going to show is a scenario where we are have what's known as a vSAN Max storage cluster, and we just want to start small. We heard about, oh, you can use vSAN just as your centralized shared storage. Hey, this will be great. Let's just try it out. So it makes sense to start out small. So in this particular case, you can start out with a 4-host cluster. Now, from this point, you can mount the data store, and you have your vSphere clusters. They'll be able to use that data store just like they would for anything that's living on your storage array. But let's say that's worked out really well, and maybe you want to increase the number of vSphere hosts that you have here. Again, that's been the flexibility, of course, of any sort of compute level virtualization. But where the real benefit of this comes in is that you can say, now that I'm using more resources, Now I just need to add a few more hosts if I want to expand my capacity or expand my performance. This was historically much more difficult when you were trying to size a traditional 3-tier architecture where you're looking at what sort of a head unit should I buy on my next modular-based storage array? What sort of, how powerful of storage controllers need to be here, and what does that look like? Is that powerful enough for today, tomorrow, next year? You're not quite sure. In this scenario, just go for what you need right now. Your performance capabilities really are a byproduct of the specifications of the server and the network, not the size of the cluster, not the host count of the cluster. And of course, then from this point, you can just scale this as needed, regardless of what your needs are. So, all right. So next part, availability, really, really important. If you can't make something available, you're not going to last long in this industry as a whole. So first up is, vSAN makes it fairly easy to prescribe a certain level of resilience and just let vSAN take care of the rest. You just define the outcome, it's going to take care of the rest. But it assumes that you have a sufficient number of hosts in order to do that in the first place. So let's look at what this actually looks like. And we're going to be using the vSAN Express Storage architecture as an example here. But let's say we're using a RAID 5 erasure code. Now, with ESA, we actually only need a minimum of 3 hosts in order to use that very space-efficient erasure code. But if you have a host fail, yes, the data will still be available, but you're running in a degraded state, meaning that you can't suffer an additional failure while maintaining availability. So what we recommend in this particular case is have at least one more host. That means that if you have a sustained failure, that it has an opportunity to rebuild the parity and the data somewhere else so that you can regain that prescribed level of resilience. And the same thing goes for a little bit larger cluster. If you want to do something like RAID 6, which is I always recommend anyway, we need a minimum of 6 hosts in order to satisfy that storage policy, but I really recommend 7 at a minimum, because then that gives you the opportunity, if you have a host failure or just a maintenance window where you're pulling one into maintenance mode, but you want to make sure that it gets back to its prescribed level of resilience, this is the way that you should do it. If you have clusters that are, 9 hosts, 12 hosts, 16 hosts, 24 hosts, yeah, this is all irrelevant. You have more than enough hosts. This is really geared toward the smaller scenarios here. Next up, use trusted platform modules within your hosts. Regardless of what you have, if you don't think that you need encryption, buy them anyway. They're only about $50 within the specifications of a BOM, and that is really something that, but it's going to give you this ability to persist these keys that are stored from your key management server or the native key provider within the vCenter server, so that you are not depending on that vCenter server for the purpose of issuing the key in the event that you need to reboot a host, but the key server is not available and so forth. It's the greatest form of durability that you can provide. I just would really highly recommend it. So we're just going to step through what this looks like here. In the event that you have an issue with the actual key provider, this is all going to be cached. These keys will be stored cryptographically on this key store, so that then it can be loaded in to memory once it is restarted. All right, and we only have 40 seconds left, so I'm just going to make this as one of my last slides here. But with regards to performance, if performance is your key importance, make sure you're using higher specifications on those ready nodes. It has really no material impact on the size of the cluster. That's not going to increase your performance. It's all about networking, and it's all about the componentry within the actual server itself. So with that, I think I'm going to have to call it a day here on this. My apologies, but this, I was told to put this slide up with regards to an opportunity for you to win some neat prizes. Again, thank you very much for attending. Really do appreciate you being here. If you have any questions here, I have a few moments before my next session, so thank you very much.